Once again, good morning and welcome to our general mathematics class. Today we'll tackle lesson 3.4 and it's about exponential equations and inequalities. To start with, let's recite today's memory verse. It's found in Deuteronomy 10 verse 17 and our keyword is not partial, no favorites, equal, so no inequalities. Our memory verse today says, "For the Lord your God is God of gods and Lord of lords, the great, the mighty, and the awesome God, who is not partial and takes no bribe." Now, for your VCA boosters today, you will explore the lives of different Bible characters and how they are exponentially blessed. Oops, yes, thank you so much. I forgot to. How about this one? Is my screen now moving? Give me a thumbs up, please. If you could now see my screen moving, thank you so much for that. I keep on forgetting to do the other one. Now, for our MVCA boosters today, we need to explore the lives of different Bible characters and how they are exponentially blessed in different ways. So you just choose two Bible women and write in what ways were they blessed. You can explore the life of Hannah, the mother of Samuel, Esther, the queen, the Shunammite woman, the widow of Zarephath, Sarah, the wife of Abraham, and also of Mary Magdalene. Now, at the end of today's lesson, we'll be able to do two things. First, distinguish between exponential function, exponential equation, and exponential inequality. There are 5 items for this in a matching type. Then the second one, another 5 items for solving exponential equations and inequalities. Here's our venture with me activity today. What is the value of n? If you see, our variable is found in the exponent. So this is called an exponential function. The area A of n affected by the increase of insects is given by the equation, where n is the number of days after the initial observation. How many days will it took for the affected area to reach 100 square meters? Now, what are we going to learn today? Let's have a very brief review on what an exponential function is. An exponential expression is any of the form of b to the power of x plus d. And remember, our b should be greater than 0 and not equal to 1. Now, our exponential expressions can be an exponential function, an exponential equation, or an exponential inequality. Now, how do you know it's an exponential function? If our exponential expression is equated to f of x, or another is it's equated to y. Examples: f of x equals 3 to the power of x. Another, f of x is equal to 7 to the power of x. The next one, exponential equation. If the expression, example 4 to the power of x, has an equal sign, and it's equated not to y, but to another number, then we call it an exponential equation. The last is exponential inequality. Similar to the second one, our exponential expression but this time we have an inequality sign. So we call that an exponential inequality. But if the variable is not found in the exponent, then it's none of these three. Let's have a very brief exercise. Prepare your chat boxes. Now, can you tell me what number one is? F of x equals 5x squared. Is it an exponential function, exponential equation, exponential inequality, or none of this? Give me your answers. Here, sometimes you get confused because there's f of x. So you assume it's a function, right? But the main question is the variable in the exponent. The exponent is 2. Therefore, it's none of this. How about number 2? Number 2. 2 is greater than or equal to 1/2 to the power of x. Ready? In 5, 4, 3, 2, and 1. Very good. Exponential inequality. How about number 3? Number 3. 7 to the power of 4x is equal to y. 7 to the power of 4x is equal to y. In your chat boxes, 7 to the power of 4x is equal to y. Wait, I'm camera. Okay, so what's the answer? Some of you would say it's an equation because of the equal sign. But if you see, it's equated to y, or y is equivalent to f of x. Therefore, this is an exponential function. Very good. How about number 4? Number 4. 4, quantity 10 to the power of x minus 2 is equal to 500. 4, quantity 10 to the power of x minus 2 is equal to 500. Ready? In 5, 4, 3, 2, and 1. Now, you check. Is the exponent a variable? Yes, right? Therefore, this is an exponential equation. Next, number 5. Number 5. 7 is less than 14 to the power of x plus 4. Again, 7 is less than 14 to the power of x plus 4. Again, you need to check first. Is the variable found in the exponent? Yes. And there's an inequality sign, so it's an exponential inequality. Next, number 6. F of x is equal to 0.5 to the power of x. F of x is equal to 0.5 to the power of x. Check again. The variable is in the exponent, okay? And it's equated to f of x. So it's called an exponential function. Very good. Thank you for participating in our short activity. Now, this time, let us learn how to solve exponential equations and inequalities. Ready? Now, how to solve? The first step is you need to write the equation in the same base. Again, they must have the same base. Example, our equation is 2 to the power of x equals 4. You need to write both on the same base. And 4 can be written in base 2. It's 2 squared. So we need to write both in the same base. The next one, cancel the base. So if we had the same base, you cancel the base and you work on the exponents. So x equals 2. Then you solve for the value of the variable. So x is equal to 2. Let's have some properties first. Now, if you're solving with exponential inequalities, here are some properties to remember. Now, if you have this sign, then just cancel the base, copy the exponents. But here, if your b is a fraction, then it's decreasing. It means that x, copy the x, and then this one is less than 3. Now let's have some examples, okay? First one, 2 to the power of x minus 3 equals 32. Here's your hint. The left side is in base 2. So we need to write 32 in base 2. So that's 2 times 2 is 4, times 2, 8, times 2, 16, times 2, 32. So 32 is written as 2 to the power of 5. We have now the same base, so we cancel the base. Then we copy the exponents. X minus 3 is equal to 5. Transfer 3 to the other side. We have x equals 5 plus 3. So the answer, x is equal to 8. Do you have any questions? No questions? Then we go to the next one. Ready? Okay. Can you write in the chat box? Can you write 49 in base 7? Write 49 in base 7. Ready, the chat boxes? How do we write 49 in base 7? You need to practice this. Very good. 7 squared, that's 49. But remember, we still have x in the exponent. So you write x also, equals 7 squared. We now have the same bases, so cancel the base. Then we equate the exponents. 2x is equal to 2. Divide both sides by 2, so x is equal to 1. That's our answer. Next. Okay, here. That's 4 over 9. You need to think first. Wait for a while. 4 over 9. Can I write 243 in 4 over 9?
No, ma'am.
No. So, but if I'll change them, because if I'll make it 32, if I'll make it 9 over 4, the other side becomes 243 over 32. Then these two are almost related, right? Now, can you write 243 in base 9? Can you write it in base 9? Actually, you can do, example, this one. 9 to the power of 1 is 9. 9 to the power of 2 is 81. 9 to the power of 3 is more than 700. So no. But 9 can also be written in base 3, and 243 can also be written in base 3. So here's what we'll do. For 32, it can't be written in base 4, but 4 can be written in base 2, and 32 can be written in base 2. So let's write them both in base 2 and in base 3. Let's start first here. Ready? 4 can be written as 2 squared, base 2. 9 can be written as 3 squared. And remember, we still have an exponent. 3x is equal to, now 243 can be written in base 3. So that's 3 to the power of 5. While 32 can also be written in base 2. 2 to the power of 5. Now, let's simplify first. In your left-hand side, you have both exponents too. So we can let this go out. It becomes 2/3, then the exponent 2 will go out. And don't forget to copy the other exponent, 3x. For the right-hand side, 5 can go out. So the one inside is 3/2 to the power of 5. Now the difference is, in your left-hand side, it's 2/3, while in your right-hand side, it's 3/2. What are we going to do? Actually, you can exchange 2 and 3. Once you exchange the numerator and denominator, the exponent sign will change. Example, I'll copy the left-hand side. 2/3 to the power of 2 times 3x equals this one. We will interchange 3 and 2. So it becomes 2/3 also, but the sign of the exponent will change. It will become -5. So we now have the same bases. Cancel the base. We have 2 times 3x equals -5. Let's solve for the value of x. 2 times 3 is 6x equals -5. Divide both by 6. So x is equal to -5/6. Any questions? Again, step 1, write both in the same base. Other question? No other questions? Let's go to the next example. Okay. Now again, write both in the same base. We could not write 8 in base 4, right? So what should be our base? In the chat boxes, in our chat box, what should be our base? What's common in 4 and 8? In what base can you write it? Very good, in base 2. So you can write 4 as 2 squared. Don't forget the other exponent, then less than. And you can write 8 in base 2. 2 times 2 times 2. That's 2 cubed. Same base, cancel the bases. Actually, your main challenge is only in writing them in the same base. Once you'll have it in the same base, then the next steps will be very easy. 2 times 2, that's 4x less than 3. Divide both by 4. So our answer will be x is less than 3/4. Questions? Let's go to the next one. Number 5. Okay, 3 and 9x. In what base should we write them? 3 and 9x, 9 to the power of x. 3 and 9. In what base should we write them? Very good. In base 3. That's 3 alone. Copy it. How do you write 9 in base 3? 3 times 3. So it's 3 squared. Do not forget the other exponent, x. Same base. Ma'am, there's no exponent here in the left side. What will I write? Remember, if there's no exponent, you'll write 1. Same base, cancel the bases. So we have our exponents. 1 is less than 2x. Divide both by 2. So x is greater than 1/2. Let me write that. Now, here's another trivia example. I'll write the exponent in negative number. I'll rewrite first in same basis. So it becomes 1 less than negative 2x. Here, in the inequality sign, if you divide both sides by a negative number, the sign of the inequality will change. Again, if you divide the inequality by a negative number, the sign of the inequality will change. So that's negative 1/2, and from less than, it becomes greater than. So I'll rewrite it. X, it turns its back in x. So we have x is less than negative 1/2. Questions before I proceed? I only have last 2 examples. Let's go to example number 6. Now here, 4 and 16. In what base should I write them? In the chat box, in what base should I write them? 4 and 16. Oh, very good. You can write it in base 4. So copy the one in base 4. 16 can be written as 4 squared. Same base, cancel the base. Copy the exponent. X plus 1 is greater than or equal to 2. Transfer. You have x plus 1, x is greater than or equal to 2 minus 1. So x is greater than or equal to 1. This is now my answer. It's easy, right? Let's go to the last one. 125 and 25. In what base should I write them? 125 and 25. In the chat box, share with me, in what base should I write them? There's a correct answer, in base 5. Now, remember, you can do it this way. 5 to the power of 1 is 5. 5 squared is 25. 5 cubed is 125. So 125 can be written as 5 cubed. Do not forget the other exponent. Enclose them in parentheses because you still need to multiply 3 to both numbers. The other is 5 squared. Do not forget the existing exponent, x plus 3. Same base, cancel the base. Copy the exponents. Then let us simplify. Let's do distributive property. 3 times x is 3x. 3 times -1 is -3. 2 times x is 2x. 2 times 3 is 6. Let's now simplify. Actually, the Filipino way to do it is to transfer 2x to one side, transfer -3 to the other side, right? But let me teach you how Singaporeans do that in Singaporean math. Here, subtract 2x to both sides. So you're left with x minus 3 equals 6. Transfer 3, right? So add 3 to both sides. X is equal to 9. So our answer is x is equal to 9. That ends today's discussion. Do you have any questions?
Ma'am, I have